students, welcome to day 2 of our factoring review, and we do have a warm-up, so please take a moment to try each of these questions after you pause the video, and then rejoin me when you're ready to learn the lesson about factoring x squared plus bx plus c. So take a look at the answers to the warm-up and check them against your own. Each of the skills that we've covered here in the warm-up will be really important skills throughout this lesson and really throughout this entire unit on factoring. So factors of 8 that have a sum of 9 are of course 8 times 1. So 8 times 1 would give you 8 and would have a sum of 9. Same thing with factors of 30, but they have to add up to negative 17. That would be negative 5 and negative 15, because remember, two negatives multiply to give you a positive, but of course they're going to add to give you that negative 17. And then, of course, practicing our use of FOIL. Now, it turns out today that we're going to be using the FOIL property, or distributive property, in reverse as a way of factoring. So our learning goals today are to factor a polynomial using what's called the AC method. So we're going to be using this AC method. And factoring a polynomial with leading coefficient other than 1 using the AC method. Okay, so really it's all about this thing called the AC method. So what exactly is the AC method? We'll talk about that and how we actually can use it to factor polynomials. So you learned how to multiply two binomials using the FOIL property or distributive property, and actually you just demonstrated it in the warm-up. But today we're going to learn how to factor a trinomial polynomial, in other words a 3-term polynomial, into two binomials, or what we'll call reverse order multiplication. Reverse order multiplication of binomials. So I mentioned in the learning goals the AC method. Here are the steps in using the AC method. And when we talk about AC, we're actually referring to when we have a polynomial, actually a trinomial polynomial in standard form, it will look like this. AX squared plus BX plus C. So when we say AC, we're talking about the coefficient of the x squared term and the constant term. That's what we mean by AC. So in the AC method, we first multiply the A and the C and then find the factor pairs of the product. Next, we choose the factor pair that add to equal B, which is that coefficient of the x term in the middle. So what we do is we multiply A and C. We find the factor pairs of the product of A and C that add up to B, which is the coefficient of the x. Next, we rewrite the B term as two separate terms using those that factor pair as the coefficients of the two terms. And then finally we factor by grouping. So what better way to learn this method than actually putting it into action? So we're going to go ahead and turn the page and we're just going to get right into some examples. Alright, so we're asked to factor each trinomial, and when we're done, our goal is to have our trinomial written so that it's the product of two binomials. And so we said that in this AC method, the first step was to actually multiply the A and the C. Well, if we look at this first trinomial, x squared plus 6x plus 5, when we refer to the A, we actually mean the number in front of the x squared term. And so in this case, our A is 1 and our C is 5. So we're going to multiply 1 times 5, which is 5, and we're looking for factors of positive 5 that add up to positive 6. And so the factors of 5, since it's prime, there's just 5 and 1. There would also be -5 and -1, but this is a factor pair that works for what we wanted it to do, which is we wanted it to add up to that middle term of 6, and you can see it does there. And so we've completed the first few steps of the AC method, and so now we want to move on to step 3, which is to rewrite the middle term as two separate x terms that have the coefficients of that factor pair we chose. And so this is what that would look like. So we would rewrite this trinomial as 1x squared, or just x squared, plus, and then instead of writing 6x, we're going to write 5x plus 1x, or 1x plus 5x. And it doesn't really matter which one comes first, so I'm just going to write 1x plus 5x plus 5, which is that final term. So I've rewritten the middle term as two separate terms that do actually add up to the original 6x. And then we're going to factor by grouping, which happens when we have 4 terms. We just split them right down the middle. So I'm going to go ahead and split those right down the middle. I'm going to take a look at the first two and see what I can factor out. So out of 1x squared and 1x, I can take out just an x, or just a 1x. And when I take out that x, it leaves me with x plus 1. And when I look at the second two terms, 5x plus 5, I can take out a 5. And when I do, and that's a positive 5, it leaves me with an x plus 1. So there's my common binomial that I was looking for. And so what's left over after I factor out that x plus 1 are the two numbers left out in front, which are x plus 5. So that leaves me with two binomials that when I multiplied them back out with FOIL, I would get the original polynomial x squared plus 6x plus 5. So that is the AC method. Now in this case, it really could have been done in an even easier way, and it's a way that you may have learned to factor before, and that's because notice that the a was 1 in this case. It was just x squared plus 6x plus 5. So the factors of the a were just 1 and 1 because it was 1. And so really we could have actually done this in a little bit easier way just by looking at what are the factors of 5 that add up to 6, and it would be 1 times 5. And then 1 plus 5 makes 6. And so what we could have done is just rewritten the two binomials with the 1 and the 5, positive 1 and the positive 5, as my two constant terms, and then they both would have to start off with x. So it would be x plus 1 and x plus 5, which is what we got when we did the factor by grouping. The nice thing about the AC method is that it works for all trinomial factoring, and if it is factorable, that is. And so even when we don't have this leading coefficient of 1, which, when we have something other than 1 makes it more complicated, this AC method will always work. In fact, let's actually look at one where that leading term, that coefficient of the x squared, in other words, the a, is not 1. And that's exactly what we see in example B. So notice that the a is 3 and the c is 16. And so when I multiply the 3 and the 16, I get 48. So I'm thinking of factors of 48 that are going to add up to, they have to add up to a negative 16. So this is what I'm looking for them, my two factors to add up to. So I started thinking about different factors of 48. I thought of first of like 48 and 1, 24 and 2. I thought of 12 and 4. And now if I had 12 and 4, they'd add up to positive 16. But instead, I want them to add up to negative 16. So what about negative 4 and negative 12? Now, negative 4 times negative 12 would give me a positive 48, which is my product of my A and C. And so it multiplies to give me that 48, but it also adds to give me that negative 16, which is what I needed. So that next step is then to go ahead and take my original trinomial and rewrite the middle term. So everything else stays the same. The first term stays 3x squared. The last term will still be plus 16. But now I'm going to rewrite the middle term as a minus 4x and a minus 12x. And again, it doesn't really matter which one that you put first. I just kind of have a little bit of feeling about this. I think I like the way that the 12 and the 3 go together and the 4 and the 16 go together. So I'm going to put minus 12x and then minus 4x, or maybe plus negative 4x. But again, it doesn't really matter which of those terms come first. Now we're at that step where we have to split this up because we have 4 terms. We're going to divide it 2 and 2 and factor by grouping. So I take a look at the first 2 terms, 3x squared minus 12x. I know that I can take a 3 out of 3 and 12. I know I can take an x out of x squared and x. So my common factor, GCF, is 3x. When I divide that out, I'm left with x minus 4. I'm going to do the same thing with the second pair, negative 4x and positive 16. Remember what I said about if you're that leading or that first term is negative, you should always try to take out a negative. So I'm actually going to take out a negative 4. And that's really all I can take out because they don't both have variables. So if I divide out negative 4x by negative 4, I'm left with a positive x. And 16 divided by negative 4 is a negative 4. And voila, I have that common binomial, which is what I needed. And so as a result, my factored form would look like this. The 2 numbers out in front create one of my binomials by putting those together, and the common binomial makes the other one. So my factored form would be 3x minus 4 and x minus 4, or you could write it as x minus 4 first and then 3x minus 4 second. It doesn't really matter, but that is my factored form of that trinomial. And again, we could check that back by just simply using FOIL to work backwards. And we're going to go ahead and try one more of these together, and then I'll leave a couple of them for you to try before we move on. In example C, I've got an A of 6 and a C of 5. So when I do the A times the C, I get 30. So I'm looking for factors of 30 that add to 17. And right away those just came to my mind. But if they don't, you can just, maybe take out your calculator and just start dividing 30 by, 2. And, well, first you want to start with 30 and 1. Those don't add up to 17. Then divide by 2, divide by 3, and so on. And so you take a look at all the factor pairs and try to find some that add up to a positive 17. Now, if it turns out that you need them to add up to a negative number, just consider making them both negative, or maybe if you have a negative AC, so if this had been negative 30, then just keep in mind that one of the terms would have to be positive and one would have to be negative. But it's very clear here that I hope that this factor pair would have to be 15 and 2, because 15 plus 2 is 17. So now we're at the step where we rewrite our original trinomial, and we keep the first and last terms exactly the same. We just rewrite the middle term. So when we rewrite the middle term as a 15x and a 2x, and it doesn't really matter which one comes first. So I thought I would go ahead and put the 2x first and the 15x second. And again, if we just put those like terms together, we would be right back at the original trinomial. So we're really not doing anything except for just turning it from a 3-term polynomial into a 4-term so that we can use this factor by grouping. And all we did is take that middle term and just split it up into 2 separate terms. So now we can do the divide and conquer, or split 2 and 2. If we take the first 2 together, I could take out a 2 and an x out of both of those terms, leaving me with a 3x and a plus 1. Out of the second 2, I could take out a positive 5, and leaving me with 3x plus 1. So there's my common binomial of 3x plus 1, and the numbers out in front provide me with the terms for my other binomial factor. And so my final factored form for this would be 2x plus 5 times 3x plus 1. And again, it doesn't really matter which binomial you put first. So you could have the 3x plus 1 first and then the 2x plus 5 second. So now I'd like to have you try the next couple examples on this page independently. So we're going to leave those as the you try problems, and once you get a chance to try both of them and check your work, tune back in and see how you did. So if you're just tuning back in, I'd like you to take a few moments and look over example D and E and your answers. And if for some reason you got a different answer, and it's not just that the binomials are switched in different order, then maybe pause the video and look back through the work and see if you can follow all the logic behind that solution. So, and if you got them all correct and you understand everything, then we're ready to move on. So I'll have you go ahead and turn the page. Now, the one thing that was common in all of those prior examples using the AC method is that the A times C, the product of the A and the C, always turned out to be a positive number. And so we're going to now look at what happens if when we find the product of A and C, it turns out that we get a negative number. And so when you think about when you multiply two things to get a negative, that means one of them must be positive and one must be negative. So we'll keep that in mind as we work through these problems here. So if you look at example 1, and we notice that, or example A, excuse me, notice that x squared plus x minus 20, that the A is actually a positive 1. So I just filled that in. If you don't have a number, it really means there's a 1 there. And that the C is actually a negative 20, because that's a minus 20. So when I change it to addition of the opposite, I get a negative 20. So that means when I'm multiplying my A and my C, I'm multiplying a 1 times a negative 20, which is negative 20. And so I'm looking for factors of a negative 20 that have to add up to that middle term B. Well, that middle term B doesn't have a number there either, and that means it's also a 1. And so I'm looking for two factors. They have to be different signs, and they have to add up to a positive 1. So they have to multiply to negative 20 and add to 1. And right away, I start thinking about 4 and 5. 4 times 5 is 20. But if I made one of those positive and one negative, in order to get a positive 1, I'd have to make the 4 negative and the 5 would have to be positive. So negative 4 times 5 is negative 20, and when I add those, I also get that positive 1 that I need for that middle term. So then I think about just rewriting this. Again, the first and the last terms stay the same. So the first term is going to be x squared, the last term is going to be minus 20. I rewrite the middle term of 1x into a negative 4x and a positive 5x. And again, it doesn't matter which one comes first. It's up to you. So let's say I wrote it as minus 4x first, and then plus 5x next. Now I've got my 4 terms that I need to do my factor by grouping. So I'm going to split them up. I'm going to take the first 2 together and take out the common factor of x, which leaves me with x minus 4. And out of the second 2, I have a common factor of 5, and that leaves me with x minus 4 again. And there's that common binomial that we're always looking for. That tells us that it is actually factorable. So that means one of my binomials is that x minus 4, and the other one is the numbers that come from out in front, and that is the x and the plus 5. So that's going to form another binomial. That's one of my factors. Okay. So I get sometimes I'll have people say, well, why do you not write x minus 4 twice? Because it appears twice. Well, remember what we're doing is it's like we're doing the distributive property in reverse. So it's like that the x minus 4 is being multiplied by the x, and then the x minus 4 is being multiplied by the 5, which is exactly what would happen if I took this final factored form and used FOIL or used the distributive property on it. That each one of those terms, the x would be multiplied by both the x and the minus 4, and so would the 5. So that, in effect, is, the x and the 5 are both being multiplied by the x minus 4, and that's why we don't repeat that binomial in our final factored form. So why don't you go ahead and try example B as a you try. So go ahead and pause the video now, try that, and then tune back in, and we'll work C together. So that one turns out to be x minus 6 and x plus 3 as your two binomial factors. Again, either order, doesn't matter which one comes first. And you know, to be honest with this one, notice I didn't show any of the work. And that's because I went back to that easier method. And remember I said that that is okay if your leading term or your A is 1. Because basically that, that middle term, that minus 3, comes from just the factors of the C, because multiplying something by 1 doesn't really affect it at all. So really, I could have just thought about, well, factors of negative 18, and I thought of negative 6 and 3 right away, because I know that they have to multiply to give me negative 18 and add to give me negative 3. And so I know if I use those as my two constant terms, and I know to get x squared, the only way I could do that is by having both of these first two terms in the binomials to both be x. So that is a shortcut you can do if the leading coefficient is 1, as was the case in example A and example B. Okay, let's just quickly work through one more of these together. So I've got 2x squared plus 9x minus 18. So my A and my C. My A is 2 and my C is negative 18. So I have 2 times negative 18, and that gives me a negative 36. So I'm thinking about factors of negative 36 that have to add up to 9. I usually think when I think of 36, I think of 9 and 4, but you know, since one of them has to be positive and one has to be negative, that's not going to work out to give me 9. And so I have to think of another pairing, and so probably the next one that comes to my mind are 3 and 12. I know 3 times 12 is 36. And so I know that if I want it to be a positive 9, I'd want the larger of those numbers to be the positive one. So I thought about 12 and negative 3. And 12 and negative 3 would go ahead and add up to that positive 9 that I need them to. So then next step is go ahead and rewrite your trinomial. First and last terms will be exactly the same. The middle terms will get, we'll take that middle term and split it into two separate terms that will add up to 9x. And again, it doesn't really matter which one comes first. So I think I'm going to go ahead and I'm going to put the plus 12x first, and then the minus 3x next. Then I'm going to split these up to go 2 and 2. And when I do that, because in that second grouping of 2, I have a minus 3x, I usually just go ahead and rewrite this as plus a negative. Now I'm going to take a look at the first pairing, and they have a common factor of 2 and an x. When I factor out 2x out of 2x squared, I'm left with x, and out of 12x, I'm left with 6. In the second pairing, I have a leading coefficient that's negative, negative 3. So I want to try to take out a negative 3, and when I do, I divide negative 3x by negative 3, I get positive x, and when I divide negative 18 by negative 3, I get a positive 6. And so I've got that common binomial that I needed, which tells me this is factorable. And so my final factored form will be 2x minus 3 times x plus 6. And again, the order of the binomials doesn't matter. So you could put the x plus 6 first. And that's our final answer. Okay. I do want to look also at example D with you as well. And that time, what's interesting to note about this one is that the leading coefficient, the A, is actually negative as well. And so we'll see how that looks when we have to factor out when the leading coefficient is negative. So the way that I choose to approach, and there's different schools of thought with that, but the way I choose to approach something like this, when that leading coefficient is negative, is I will immediately factor out that negative. And so I'm going to go ahead and take out that negative and divide it out of everything, which is going to change the sign on everything. So that becomes 6x squared, and then plus 17x and plus 12. And what I do is then I deal with just factoring that trinomial 6x squared plus 17x plus 12, but I have to be mindful that there's this negative out in front. So in my final answer, I know that I'm actually going to have that negative out in front. So I'm just going to kind of transfer that down, my final answer, and I'm just going to deal with 6x squared plus 17x plus 12, and that's much easier to factor. So I go to work on that. I take my 6 and my 12, multiply 6 times 12, and that has a product of 72. So now I'm thinking of factors of 72 that add up to 17, and immediately I thought of 8 and 9, because 8 times 9 equals 72, and 8 plus 9 equals 17. So now I'm going to split that middle term up. And again, I just keep thinking about that negative's out in front, so I just want to carry it along. So I can put whichever one I want to put first, whether it's the 8x or the 9x. I think I'm going to start off with the 9x. I just think it goes along with 6 better than 8. I don't know. It doesn't really matter, though. And now I'm going to split those 4 terms up, 2 and 2. I'm going to take the first pairing and take out a 3x out of both. And that leaves me with 2x plus 3. And then out of the second 2, I'm going to take out a 4. That's the common factor of 8 and 12. And that leaves me with 2x plus 3. And there we go. We've got our common binomial factor of 2x plus 3. And so with that negative out in front, and I've already taken that into account in my answer, so one of the binomials will be the two numbers, of course, that are out in front, that 3x and the 4. So that's one of my binomials is 3x plus 4. And my other one is 2x plus 3. So if I were to FOIL that back out and then distribute that negative through, I would get my original binomial. So again, just the way I choose to approach it is if that leading coefficient, that a, is negative, I just go ahead and factor out the negative and then just make sure I account for that in my final answer. So let's turn the page. So we've reached the last page of this lesson, and what you'll see here is really just more of the same type of problem. And so what I'd like to have us do with these is hold off, and we're going to do these as a warm-up in class when we meet again. So we're going to end the video here, and we're going to call this an in-class you-try. So we'll just make a little note that we're going to do this in class the next time that we meet again. So that does it for today and for AC factoring.